Questions? So figure 8.1 shows three lamps are connected, and you can see the lamps are connected in parallel, and then there's a fuse which is connected in series. A fuse like the fuse is having its own rating, there's a maximum number or amount of current which can allow, and then if the current is too high, then the fuse will melt. So figure 8.1 shows three lamps and a fuse connected to a power supply. The electromotive force or EMF is 240, and each lamp is labeled 240 and power is 40. 220 and power is 40. The rating of the fuse is 2 amp, means the each like the fuse maximum can allow 2. If the current is more than 2, the fuse will blow. So we want to calculate the current in each lamp. How to calculate the current in each lamp? So the power of the lamp is given, because I mentioned this is the power of the lamp, and voltage is also given. So formula which relate the power, voltage and current. So P is equals to VI or P is equals to IV. Where P is the power here, which is 40, V is the voltage 220, and I is the current, we don't know. 220 is multiplied, other side will be divided, so it will be 40 divided by 220. So 40 divided by 220, that will give us 0.18. So the current in each lamp is equals to 0.18, means 0.18 ampere will be across this one, 0.18 ampere across the second one, and 0.18, because all lamps have the same rating, so they will have the same current. And if 0.18 amp multiplied by 3, what is the total current which enter? The total current which enter should be equal to 0.54, because that 0.54 ampere divided into 0.18 in lamp 1, then remaining 0.18 to lamp 2, and the 0.18 in lamp 3. So the current in the fuse, how to work out the current in fuse? As we did, like we got the current in each lamp which was 0.18, and the total current, because the current in the fuse is the total current, which is a sum of the current in each lamp as they are in parallel, or we can also multiply by the number of the current in each lamp multiplied by the total number of the lamps, we can find the current in the fuse. Then the total number of the lamps which can be connected in parallel without blowing the fuse, like the how many lamps can be connected in parallel so that the fuse will not blow. So how we know how many lamps we can connect in parallel? We know current in each lamp is 0.18. If we connect another lamp, then another lamp, so current, how many lamps should be connected with? So maximum current which the fuse can allow is 2, and the maximum current in each lamp is 0.18. So how to get the number of the lamps? If one lamp is 0.18 and maximum 2 ampere can pass, so it will be 2 divided by 0.18. So 2 divided by 0.18, this will give us 11.11. So 11.11 lamps can be connected, but 0.11 lamp does not make different like effect. So this means how many lamps can be connected before the fuse will blow? We can connect 11 lamps, because when we connect 11 lamp, each lamp is having a current of 0.18. So 11 lamps multiplied by 0.18, that is 1.98. So 1.98 will not blow the fuse, because fuse maximum can allow 2 ampere. But if we connect the 12th lamp, so 12 multiplied by 0.18, that is 2.16. So that current will be higher than 2, or the fuse will blow. So the total current divided by the current in each lamp, we can identify the number of the lamps which can be connected to a circuit. Is it clear, this question? The next question, current and voltage graph. Whenever current and voltage graph is there, current on y-axis or voltage on x-axis, the slope is reciprocal of resistance. So what happened here, we observe the slope is decreasing. If the slope is decreasing, it means the resistance is increasing. So in the question, they ask what happened to resistance from 0 to 1 volt. So from 0 to 1 volt, it is a straight line. So till this point, it is a straight line. So if it's a straight line, it means resistance is, because the slope is constant, straight line, slope is always constant. So if the slope is constant, we can say the resistance is constant. But what happened afterwards? For this part, the slope is decreasing, the blue part. So if the slope is decreasing, what we can say? We can say the resistance is increasing, because the current on y-axis and voltage on x-axis, the slope is reciprocal of resistance. So if the slope decreases, it means the resistance is increasing. So in the question, they're asking what happened from 0 to 1 volt and from 1 volt to 8 volts. So the first part, the resistance is constant because the slope is constant. And the second part, the resistance is increasing because the slope is decreasing. At a normal brightness, the potential across the lamp is 8 volt. What is the resistance? So we have to use a graph here. If the voltage is 8, we need a resistance, so we should know the current. So when the voltage is 8, we will find the current, and because from 0, like 10 boxes equals to 0.2, so it means each box is 0.02. So this is 0.62, 0.64, 0.66, 68, 72 and 74. So this will be 0.74 ampere. And we know the voltage is 8, so we need a resistance. Resistance is voltage divided by current. So voltage is 8 and the current is 0.74. So 8 divided by 0.74 will give us the resistance, which is 10.81. So resistance is 10.81 ohms. So using the graph, we work out as the voltage is given, it was 8 volts. So we work out the current at 8 volts, and from this voltage and current reading, we calculated the resistance of this bulb or a lamp or a filament lamp. Then we need a power. Power is a product of voltage and current. So we already work out the current was 0.74 that we did. So resistance was voltage divided by current. So it was 8 divided by 0.74, we got 10.81. And to get the power, power is a product of voltage and current. So voltage is 8 and the current is 0.74. So 8 multiplied by 0.74, that will give us 5.92 watts. So unit of the power is watt, that's why it's 5.92 watt here, where resistance is ohm, which is a ratio between voltage and current. Then 5 of these lamps, like the lamp which is shown here, the 5 of the lamps are connected in parallel. Determine the electromotive force or EMF. So how to work out the electromotive force or EMF of the battery? Each lamp is 8 volts, like, and we know when lamps are connected in parallel, they will all have the same volts. So if this is 8 volt, this will also have 8 volts, 8 volts, 8 volts, 8 volts, and the power supply means that is also 8 volts. So what is the electromotive force of the power supply or voltage of the power supply? That's also 8, because whenever components are connected in parallel to the supply, they all have the same voltage of the supply. Then the total current from the power supply. How to get the total current from the power supply? Because we already calculated in using a graph, we work out the current in each lamp is 0.74. So this was 0.74. This is also 0.74, 0.74, 0.74 and 0.74. So 1, 2, 3, 4, 5 lamps are there. Each lamp is 0.74 current. So what is the total current which enter the supply? So 0.74 multiplied by 5. So 0.74 times 5, that's equal to 3.7 ampere. So 3.7 ampere is the current which enter the supply from the supply to this circuit, and then it divided into 0.74 in each lamp. So the final answer is 3.7, because the current in each lamp multiplied by the total number of the lamps. So one lamp, the current is 0.74, which we got from the graph, and multiplied by the number of the lamps were 5, so that's why it is 3.7 amperes. Is it clear? Discussion that how we work out the electromotive force and current in each lamp. So remaining questions will continue in the next session. Tomorrow we'll do more questions related to the topic.